Hello, and welcome again to Chemistry with Mr. Olson. Today, we're working on the mixed reactions worksheet, and first, let's do problem number 6, in which we are deciding which element is oxidized, which element or elements is reduced, gives us a clue, one of each. And here's the equation. Fluorine, F2. Now that's a neutral element, so that will have zero charge. I'm going to put a 0 above that just to stress, hey, neutral element, no charge. KBr, and let me get this out of the way. KBr, that's ionic, potassium bromide. Looking at our periodic table, potassium +1. Bromine, let's see, noble gases have zero charge. We count 0, -1, -2, -3. Bromine is a halogen, -1 charge when it gets the electrons it wants. So that's a +1 above the potassium. Each bromine is a -1. And on the right side, KF, +1 and -1. And bromine as an element, Br2, sharing its valence electrons, we have a 0 charge as a pure element. So I always like to figure out what's reduced. What went down? Fluorine went from 0 to -1. That's going down. That is reduced. So fluorine was reduced. And let's see, potassium went from +1 to +1. It didn't change. It's what we call a spectator ion. It's just watching. It's being fought over by the halogens. And the bromine went from -1 to 0. -1 to 0, it was increased, so it was not reduced, it was oxidized. So that is the bromine. The bromine was oxidized. There we go. Now, let's do problem number 9. That's a very interesting one. Here we are predicting the products and writing the balanced formulas and then balancing the reaction. Sodium and water form what? How are we going to predict that? Well, let's write the formula for sodium. Sodium as a neutral element with its valence electrons, Na. And water, H2O. I'm going to write water a different way, HOH, which stresses that water can be viewed, and it happens as it is in some reactions, as H+ and OH-. So here, and forgive me, I'm going to draw a little pencil arrow here. Well, maybe I won't. Maybe I will temporarily draw a little post-it in. The sodium is going to cut in and replace the H+, and it's going to end up with the OH-. So now we have NaOH, and it's replaced the hydrogen. So we have hydrogen as a product. It's how it got the valence electron. And hydrogen is a Brinkelhoff element, H2. So +1, -1, sodium hydroxide, H2, hydrogen. Once we get the, and we can complete the English sentence. Sodium and water form sodium hydroxide, and hydrogen, or hydrogen gas, because it'll be bubbling hydrogen. And now we need the balance. So let's see, 1 sodium, 1 sodium, 1 oxygen, 1 oxygen. If we treat the OH as being there, we need, we've got 2 hydrogens left over here with 1 here. We're going to have 2 waters. So I'm going to do this in pencil just to be cautious. 2 waters. That makes 2 OHs. We need 2 of these and 2 sodiums. And I think that balances. 2 sodiums, 2 sodiums. Let's count all the hydrogens together. 4 hydrogens, yes. Balances. Done. Okay, next reaction, sulfuric acid and barium nitrate.
sulfuric acid, H2SO4, one of the strong acids we memorized, plus barium nitrate. Barium is an alkaline earth metal, +2 charge. So that's, barium nitrate is, of course, the NO3 -1 charge. Let me write that in some other color. So NO3 with a -1 charge, and the barium is Ba +2. That will make barium nitrate. We need 2 nitrates, 2 NO3s. And there are our reactants. And we need to predict products. We need to predict products. The best way is to recognize what type of reaction this is. It looks like a double replacement reaction. That would mean we are swapping cations and anions. Let's see, sulfuric acid dissociates into 2H+. I'll just write the H+, that's the cation, and 1SO4 -2. And now we're going to predict the products. Very important, first get the chemical formulas right and only then balance. Don't become distracted with balancing issues. Oh, I've got 2 hydrogens, 1 hydrogen. Forget it. You've got some H+, and it gets a new partner. Now it's not with the sulfate, it's with the nitrate. So that means HNO3. H+, NO3-. The simplest combination is HNO3 plus. Now the other combination is Ba +2 and SO4 -2. The charge is balanced, so the formula is BaSO4. We also want to complete the English form. You can either call this nitric acid or hydrogen nitrate. I'll call it nitric acid since we had sulfuric acid in the beginning, but could call it either. Nitric acid. And what else is formed? Barium sulfate. Ionic compounds, we just name the cation and anion. Barium cation and sulfate. So that is our English. And now that we've done that, we need to balance. Things look good. 2 bariums, a barium on each side, a sulfate on each side. But here we have 2 nitrates. We need 2 nitrates over here. I'm going to do it in pencil just to be cautious. 2. And that also fixes our H's. So there we go. Our balanced equation. One last one to do. Nitrogen and hydrogen form. So nitrogen, that's diatomic nitrogen. And hydrogen, another Brinkelhoff element, H2, form, that's the arrow. What can we make? Well, hunk 1, 2, 3, 4 means nitrogen makes 3 bonds, hydrogen makes 1. That brings us ammonia, NH3. And here we're not balancing charges. We've got 2 nonmetals. They're both nonmetals, so we just use the number of bonds they form. Ammonia is what that's called, ammonia. A weak base that we memorized the formula of. And now that we've got the English and the chemicals, the chemical formula right, now we balance. We're going to need, since it's N2 on that side, we need 2 NH3. And now all we have to do is balance the hydrogens. We have 2 times 3, 6 hydrogens on this side. We have 2 NH3s, so we need 3 H2s, 3 hydrogen molecules. And that's how we predict some products, write the English, and balance the equations. Remember, when you create one of these equations, first get the chemical formulas correct, and only once you've got the chemical formulas correct, then balance the equation. Thank you for visiting. Have a beautiful evening. And here we go.